All right, let's look at an example with a little bit more complicated denominators here. We want to look to see if we can factor the denominators. Multiplying, and let's be clear, would you like to multiply these denominators together to get a common denominator, knowing you'd have to take this, multiply it times the top, take this, multiply it times the top as well over here, FOIL that entire mess out, combine all of those terms together, and then see if you could factor and simplify? That seems like a pretty arduous process. Like it would take a lot of work, right? Let's do a little legwork now to make the problem simpler. You have to ask yourself, can I factor the denominator? Obviously down here, no. So this is not going to change. This one over here, however, is a quadratic trinomial. Maybe I can factor it into two binomials. Up top, x plus 3 is x plus 3. But on the bottom, maybe I can do x and x, find two numbers that multiply to be -6 and add to be -1. That would be -3 and +2. So my denominators parts, if you will, are x minus 3 and x plus 2. Over here, I have an x minus 3. So now looking at it this way in its factored form, would it have made sense to multiply this over here to get a common denominator? No, because I already have it there. I would have brought it something that already existed, a factor that was already in the denominator. No, I don't need that, right? But this has an x plus 2 in the denominator, and this does not. So if I want those denominators to be common, then I need to multiply this fraction by x plus 2. On the top, on the bottom, okay? So I have x plus 2, x minus 3, and on the top here, this is a binomial times a monomial, so I'm going to distribute that. 2x squared plus 4x. Plus now we're adding, always got to be cognizant of that. What does cognizant mean?
Aware.
Aware, very good, very good. Always want to be aware of if I'm adding or subtracting, right? Because if I'm subtracting both terms. But it's addition, I don't need to worry about that. So I'm adding x plus 3 with this denominator. And trust me when I tell you, when you get to pre-calc, having a factored denominator is always better. It's always better than having this mess, okay? Believe me. When you start talking about vertical asymptotes and all of that fun stuff and holes in the graph, and when we're doing trigonometric identities and trig proofs, right? Yeah, I know. No, they're not that bad. They're actually kind of fun. But when you get to that, having a factored denominator is way easier. So get in the habit of doing this now. That's why we're spending so much time on this stuff, right? 2x squared plus 4x plus x plus 3. Combine your like terms. 2x squared plus 5x plus 3. And on the bottom, leave it like this. That's okay. That's okay. All right. On the top, we don't need to worry about it. Since we took the time to factor this and recognize the only piece that was missing, we made it, how do I put this? We made the denominator bigger, but we didn't make it so big that we're going to have to reduce it later on. We didn't go beyond what we needed to do. We did exactly as little as possible, which is, right? Isn't that what teenage years are all about? Doing as little as possible and getting as much credit as possible, right? You guys know what I'm talking about. You're teenagers, okay? Trying to do as little as possible to get where I need to go, right? Not doing like even 1 minute more. No. Just tell me what I need to do to like just barely get it, right? That's like, you guys are looking at me like I hurt your feelings. All right, I'm sorry. Or are you just tired of me talking?